So thank you very much for coming here to know a little bit more about Bitvavo and what we do. I really appreciate your time and you being here, interested in this crypto market, which is such a new, like it's a new thing that's like really the path forward. We believe strongly in this, and to learn what we're doing in terms of technology, which is quite interesting. And just a heads up, this is not a deep dive technical in terms of coding, but it's very interesting from the architectural point of view. And for you to also understand what the JVM can do in terms of performance, scalability, that many times I think it's overseen. People don't really realize how powerful it can be. And I've been in so many discussions, believe me, about this, low latency with JVM. And I'm going to show some numbers. We have some people here who helped to build this, what I'm showing today. So if you're also curious to know more details after the talk, because of course it's a very short talk, I cannot really explain details, but they're here. There are some colleagues here. Feel free to reach out to them. I'm sure they will be up to talk to you guys specifically about these patterns and things you have to use for very low latency. And in the end, I'm going to show a little bit how we handle this market data going away from this core engine we call in an exchange. So that's basically the agenda, very quick. Of course, you need to know a little bit about Bitvavo. I think one thing that I've learned with Bitvavo is traveling and speaking about it. A lot of people don't know how big it is in Europe and even worldwide when you talk about Euro trade pairs in crypto market. And it's really the biggest crypto exchange in Euro pairs in the world, and it's not so well known. But now with the maker and the license, I'm going to explain a bit as well. We're really going to expand more aggressively across Europe, so we're going to hear more about us. And also, if you're interested, we are still growing, so it's really interesting. For you to look as a technical challenges, we have a lot. It's really interesting technical tech stack we use, modern and really fast-paced company. We're in a scale-up phase, which is very good in terms of if you like a good technical challenge, is really great. I'm gonna talk about some little facts, and especially can Java be very fast, and you're going to see it's impressive. And in the end, we're going to wrap up with market data, how we handle the candlesticks, output from this and how we make sense of it in real time, and the decisions, why we made those decisions, why we picked certain architectural components in the end to make sure that we minimize the work, we optimize time to market, and we reduce like problems in terms of support, and we can move faster. A little bit about me. I have Brazilian roots, but I'm a Dutch citizen since many years. I live in the Netherlands for almost 12 years now with my family, big family, 3 kids, dog, everything, the full package. So you can imagine I'm very busy outside of job as well, and I'm not working. And yeah, looking forward to go back home as well tonight. I've been out since Monday in conference, so it's really looking forward to it. But it's really great to meet and see the community as well. So a little bit about Bitvavo. It was founded in 2018. What's more impressive, it's a fully bootstrapped startup. It never got VC rounds or anything. It was capable to grow with its own profit and money. And we grew from now to have over 200 engineers, around 200 engineers. We have around 2 million verified users. We're very strong in the Benelux. So we're going to talk about Netherlands, Belgium. In that region, we are extremely strong. And again, now with the regulatory requirements getting in Europe, we are going to expand more aggressively. So again, we soon should be more visible in other countries as well. Those numbers are from 2023. It's disclaimed. I'm not sure if it's disclaimed here, but I can tell you. We did 141 billion in exchange volume, which is quite impressive. And we had days that we had over 1.5 billion in trades in a single day. So, and the way exchanges make money is through fees. So you can imagine this is a good business. And also we help customers that don't know much about crypto to actually onboard in this world, right? There's a lot of customers that are more like the retail driven, that they're not experts, but they still want to put like a percentage of their investments in crypto. Bitvavo makes this very easy. One of our mottos is really to make the application very easy for retail customers as well. That's one of the things we focus a lot. Currently we have about 450 employees. So in growing. So it's quite impressive. A little bit about the crypto market, if you don't know. So this is something interesting. If you take the European crypto market, it's evaluated in about 2.1 trillion, which represents 26% of the crypto market in the world. Of course, the North America is the biggest market, and Asia is a very big market as well. Right now, we're fully focused on the European market to establish ourselves as the biggest players here, and then we might expand. But right now, of course, we have a full focus around this. Oh my God, I have an update. Let me delay it. Okay. And why crypto is growing, right? It's really important to understand the market and what's happening. One thing I find it very interesting, I have a 21-year-old daughter, and I talk to her friends, and like these young people, they really love crypto much more than traditional finance, right? And then traditional stocks. It's quite interesting because I talk to them, they're so passionate about it. So I don't see, it's really a paving way to the future. It's going to grow a lot. And you know, the most interesting thing is like step 5 of this. Let me go to it and then I can talk about it. Why crypto is growing and why it's going to keep growing, we believe it will, right? The increasing money supply, the interest rates are very low and being pushed to be even lower, and you see what's happening. And with this, you have more money supply. With more money supply, people start investing in different types of investments. It opens up opportunities. So crypto is really one of those opportunities that it's growing massively. There is a behavioral shift in retail trading. So mobile apps. So if you look at all traditional brokers, I don't know how many of you here do traditional investments, they have very outdated apps, and with few exceptions, right? You have the new banks and new brokers, but most of them is very traditional. They are not appealing to new generations, to new customers. And the crypto market did a lot of shift in these. Like we are 24/7 to start with. The traditional stocks, you have a cap, like they close on the weekend. By the way, they're also changing these. Like Nasdaq and New York Stock Exchange already mentioned in the press, they intend to start operating 24/7 because they know they cannot compete if they don't start. Because the crypto market, the new generations are used to the internet to do wherever they want at the time they want with 24/7 services. They require that, right? So they're also going that direction. But the crypto market is operating like that since the beginning. You can buy and sell crypto at any time of the day, at any day of the week. It doesn't matter. It works, right? So this is improving. Now, for high volume investors, regulations is very important. They want to protect their money. And also a lot of people don't have the technical knowledge that we have, for example, to have our own physical wallets to keep our crypto. So people also want a custodian to take care of it. And now with regulations, people will trust more and more about this because it's regulated, right? The Dutch National Bank in our case, or other entities across Europe, they are overseeing everything that's happening in the company. So you have more trust in put your money there. So this is also going to expand the market. There is the institutional adoption that's starting hard. You all see ETF, BlackRock is the biggest fund management in the world. And they already have like offers, so a lot of companies have seen this. But I think this point 5 is one of the most interesting for me. This is what is going to drive us to grow massively in the upcoming 10 years. It's like crypto is getting to a point where the adoption, it's got more like professional, and products we're going to start be built on top of crypto with more reliability. A good example is, for example, there are products like for traditional finance to buy stocks. I don't know, again, if you do traditional finance, that's a bit of that's very common, like say, in the past. But if you want to buy stocks from American companies or from Asian companies, it can be hard. You pay a lot of taxes. You have to use an app that's outdated. Right now, there are companies building, and this is happening now, it's not for the future anymore, that are going to offer that you can buy partial shares through a crypto network that guarantees backed by one. So for example, there is a Solana network, you develop a product, and if you buy a share of that product, it's backed by an ETF from Asia, for example. So now you can buy directly from your crypto provider. In the end, you're buying something that's from a stock exchange somewhere in the world, and it's just the same app, the same easy to buy thing that you have. It's no hassle anymore, no so hard how it used to be, right? So this always like accelerating. Also payments. There are certain companies in Switzerland. I was talking with a colleague here. Unfortunately, I don't remember his name. I talked to a lot of people. But he works in a bank in Switzerland, and they already enable in Switzerland crypto payment. When you're going to pay for something in your wallet, the same way you can pick different cards, you can pick your crypto wallet, and you can say, I'm going to pay with my crypto here for certain networks. And when you pay, it's actually being linked to your crypto network. So this is growing massively. And really, in the upcoming years, there is no way back. It's a better way to do things. It has full proof, right? It's validated. There is no repudiation built in on the network. Everything is there for auditing forever. So it's really a good model, and it makes it much cheaper to do this kind of operations, the infrastructure. So eventually this is like then I'm a good path. So enough from Bitvavo. Last slide, I believe. I think I have one more. I'll go fast for it because we want to see technical things. But just to consolidate, in terms of euro, denominated euro crypto pairs, we represent 56%. This is from 2023, of course. We didn't consolidate the numbers from 24, but still in the same more or less volumes. And we really dominate in the euro market, and that's what we want to keep doing. And because from the euro market, we can start expanding across the world, right? So crypto market is growing. I'm going to go fast around here. I think number 4, it's very important, so I'll leave for to render in the end. But there is a MiCAR, which is a regulation in Europe that is really going to drive mass adoption, we believe, strongly, because again, regulation will be in, and you're going to trust more. And also banks, traditional banks, will start to step in this much more aggressive now with the regulatory requirements. We are hiring, so if you want to know about us in the end, we also have something to do. We keep growing. We are looking for good engineers. We are in the wonderful Amsterdam city. It's a great place to be. The tech scene in Amsterdam is also amazing, so it's a really good place to be. But let's talk a little bit about technology now, otherwise it's too boring. I have to watch my time. Maybe I speak a bit too slow. I can accelerate a bit. So like any successful startup, I'm going to go through this. Like any successful startup, the company was built in 2018 with a focus in time to market, which is the right thing to do, right? We skip the deep technical readiness because you're testing the market. I think I always say many startups fail because they have too good engineers in the beginning, that they're too worried to do the right thing and scalable from the beginning, and takes too long. When a startup, you need to change that mindset, and what you need to do is really MVPs and critically test the market and get customers in, right? You want to make money. Customers don't care if we use Java, Golang. They really don't care about that attitude. Like the customers, they care about their experience with the product you're offering. And the Bitvavo did this incredibly well. I mean, they start 2018. I was not there, but these guys built the company, and they got a massive piece of the market. And of course, when you build like this, it works. It's reliable. But then you have what we call a good problem. You have a lot of customers, a lot of volume, and suddenly your systems don't sustain anymore. You're crashing. You are having incidents all the time because the scalability is not keeping up. And that's what we joined Bitvavo to change, a lot of us that are here today, and we start rebuilding the company, right? And it started with using connectors. We started using Kafka because everything was in the database, right? We would do analytics, we would do real-time processing, we would do application queries in real time. So all up, everything was being done in the same database. Eventually, this does not sustain. Then we started, okay, let's move all the data to Kafka. I think it's the de facto these days. Everyone, it's more and more adopting that because you can start streaming the data from your database, from your write-ahead logs, bin logs, to Kafka, and now suddenly you can get all your data into Kafka, and from Kafka you can start spreading this around. Initially we start using connectors, we start using MongoDB as well, projections for the applications. From there we start adopting better things for analytics, like we have Snowflake, and for real-time analytics we now use Imply Druid. I'm going to talk a little bit about why we choose Druid in this talk in the end, and the technical reasons around it. That's the main point, because and why it's ready for the future. This is about preparing our company to expand. Remember, our goal is to expand more and more. We need to be able to sustain much more load over the time. and that's part of the solution. Eventually, we put connectors in any direction, so now data flows free around everywhere. Systems have access to the data. Simple architecture in the end. Not too much fancy stuff, but it works really well. It's scalable, and that's really important for us. In the end, we end up with an architecture like this. I think what most people do these days, it's a central Kafka broker. You have two ways to communicate. You have contracts over Kafka, or you have contracts over APIs. And those are the two main ways you communicate inside the company and also external. The Kafka, it's a central flow of data and also enables you to build different projections for different use cases in different domains. It's very flexible in that sense, which is very powerful. Right? So we do this well. I'm not going to lie, we still have some legacy on that old technology. We all have this challenge. It takes a long time to finalize this, and at certain points we have to make trade-offs between business value and investing in getting rid of this legacy. And we have some, it's not in the important paths anymore, we're getting rid of it. But let's go to the interesting thing, and this is what you need to understand. We have a core exchange. Our core exchange is where, and we have Spring as well. I know it's a Spring conference, so don't worry, I want to talk how we use Spring a little bit, although it's not the main focus on this. But this is our core exchange. The core exchange is building a technology that's focused on low latency. And when I talk low latency, you're going to understand what we're talking about. I have some real life charts and metrics we operate on these environments. And again, there are colleagues here who built this and helped to build this. You can talk to them specifically how we do it. But we have this core, and our customers, they go through the APIs. We have a WebSocket gateway, a REST gateway. They go to the Exchange engine, which is our core, and everything that's outputting from there, it's going to Spring applications through Kafka, as you saw, and from Kafka, the rest of the organization can plug in this core. So all the trades, the order flow, goes through this very fast engine, because you want to operate extremely fast when you're talking about trading. It's about taking opportunities. Something is costing this amount, you want to buy as fast as possible to get an opportunity and make money, right? There's a lot of people automating bots using APIs to try to trade fast and make money. So sell and buy needs to be very efficient, very precise, and extremely fast, because that's what guarantees fairness. Also needs to be fair, so you need to serialize all the access if someone sends an offer before the other person. So all this technology has to do, it's in this core engine, right? And our challenge is, as this is happening, because we have thousands of requests per second, 24/7, the order flow is happening uninterrupted all the time. And sometimes the peak go from 10,000 to 30,000 in a matter of seconds, because someone tweets something, and there's a new news about something, right? There's a new rate about interest rates. It's just announced, and then this goes crazy from minutes. So you need to be fully prepared for this kind of spikes, and that's one of the most interesting challenges we have to face. With this architecture, we moved from that legacy you saw, and we're now prepared to move to keep growing. With this architecture, we have tests that we can operate up to 70, even in the core. I think 200,000 requests per second in terms of scalability. So you're really feeling ready to go forward. Right now, we operate in a normal day that's not high volume, there's no crazy news. We operate around 10,000, I'm rounding up, requests per second in the order flow. This means buy, sell orders in the engine. But we are ready to go 20 times this expense. So we really rebuild everything to be ready to keep expanding, and that's the most important thing. Now, what's the challenge here? As this gets very fast and very efficient, you need to manage and make sense of the data that's being output from this, right? It's not only changing the core, it's how you make sense of that data in real time. And we want to simplify that to reduce the workloads in our engineering teams. And in the end, just to make a very simple example, it's about this. The exchange is our core. The business is in the core exchange. Every other domain is connecting to the data that's flowing uninterruptedly, very fast, over Kafka. The domains connect to Kafka. Of course, some domains, they have iterations via fast APIs, but the majority is like this. And then you have to make sense and, for example, show the price, the real-time price for customers so they can make an option to buy or sell their own crypto, right? And today we're going to talk about this, but let's see some numbers so you understand the challenge. So this is the P90 of the gateway. So if you go back to this is about from this is from this REST gateway coming here and back, right? The time I'm going to show you first is this, is from receiving a request, processing, sending a response back. The same from this side, right? So this is the P90. It's between it's like 2 milliseconds and 1.7 milliseconds, very stable. And there's the network in between. And this is a JVM-based solution, right? So it's extremely fast. I don't know in what types of numbers you operate, but an exchange has to operate. And this is our order flow. You're really doing a mutation in terms of canceling an order, creating an order, updating an order. And that's what you're doing here. It has persistence, resilience in different ways, but it's fully fault tolerant and scalable. So, and again, this engine is ready. What's really interesting about this engine is so efficient that the more pressure you put, the faster it gets. Right now, and this is because of the flushing on the network buffers and the way it works on the low-level machine, that with not so many pressure, it relies on timeouts to flush data. You can imagine if you work with Kafka, it's like a Kafka consumer pulling data. It does every 300 milliseconds if there's not enough data to fill a buffer. But if you put a lot of pressure, then it fills and immediately goes back. So it starts to be much faster because there's more data. This is the same. And this is the WebSocket gateway, very similar. This is the P90, very stable. So there's no spikes and things on the P90. On the P99, you have some spikes. This might go back milliseconds, but not much more than this. Not like hundreds of milliseconds, so a few milliseconds more. And then when you talk about the core engine, which is the exchange engine, then you see, okay, this is the number of requests, just an example. I forgot I had this slide. So you see this is in a 12-hour period. We're processing like millions of messages, billions of messages in certain aspects. Like the volumes are extreme, and because it's 24/7, everyone receiving that data can also not stop, right? You realize the situation. You have to provide this feedback in the app and everything, and that's what we're going to show. And this is the time inside that engine. We're talking about between 5 microseconds and 2.8. This is the P99 percentile on the core engine. Once it receives the request and to the point that outputs the response, it takes like 5 microseconds. And this, again, is JVM-based. Of course, the way you code this is not the traditional way, right? There are techniques. I spoke a little bit about this last year. I don't want to repeat. There is a talk in Spring I/O from last year where I spoke about this in more details. And there's also a lot of videos outside there if you want to understand how low latency work has to be implemented. But it's extremely fast. And again, this is JVM, because I have a lot of questions like, why you don't use C or Rust all the time, even internally? It's like, I see my colleagues here, we discussed this a lot. But the goal is, if you're doing the same language, it's much easier for you to work, for example, on the Spring Boot applications around. It's the same. We use Kotlin, by the way. We thought about Java. We decided Kotlin because we felt it's a more modern language. We adopted it 3 years ago when we start moving from that legacy to the new stack. And it's very successful. I mean, and you can also work in this core. Although the way you build this is very different than a Spring Boot application, the language behind it is the same. So the concepts you can apply and migrate. It's very easy for you to work on the whole stack. With that, let's take a look how we do the Candlestick charts. Because again, one of the biggest challenges is outputting the data from that very fast engine, right? The Candlestick charts is this. You're probably used to this. So this is about a simple candle like this. I'll quickly explain. It has for a specific interval. Let's say this is 5 minutes. It could be 1 minute, 1 hour. Doesn't matter. What it does is for every candle, you see there is this thin layers and there's the deep layer, the more what's the word in English? Okay, I forgot. But anyway, you understand what I'm saying. I'm talking about. So, and this represents the open price, the close price, the volume, It's the how much volume was traded in that interval, and the highest and lowest price in that interval. So it's about, let's say there's 1,000 trades. This summarizes those 1,000 trades in one single point of data, saying, okay, this was the highest price in those 5,000 price, this is the lowest price, this was the open price on that interval of 5 minutes, this was the closing price, and how fat the candle is how much volume it has. So here at the moment there was a lot of people selling, you see? Because it was, you understand, right? So it's single representation that you can quickly visualize and have an idea how the market works. But to be able to do this effectively, you have to process all that output data in real time. And you want to do that, this is for humans, right? Because it's visual, so we want to do this sub-second. So because you want from the trade happens to the moment you can see this, for humans, it should be sub-second. Right now we are in about 300 to 500 milliseconds to be able to update this. And we're definitely going to improve even further, but it's a very good model. And first, before we go to the current solution, let's see how it was built before. Again, in the old model, when you have a database, everything was a cron job. In the past, we used to have this, right? Everything was in the database. It would have a specific asset. We would have a very normal cron job or job that would run every 3 minutes, get all the trades for every asset. Remember, we trade over 350 different assets. When I say assets, Bitcoin, Ethereum, Solana, we trade over 350. For each one of those, these jobs, they would have to go to the database, get all the trades for that interval, calculate the candles, do a projection, insert back, and then you could finally query that data. The problems we start having is a lot of times, if the market was too hot, it's not scalable, because when you do a query like this, if you have thousands and thousands of trades in those intervals, it's not capable to keep up. In those 3 minutes, it cannot calculate all the candles, ranges for all the markets, and suddenly you would start losing candles in the map. We would start having, so that's a scalability problem. In the beginning, it worked really well. The company was there and out, but again, at a certain point, that doesn't meet anymore. We need to change that, right? So we had to change from something like this, from a cron job that would read all the fields are the trades, and would calculate every candle for every asset, for every interval, and insert, and then finally would be able to access that data. And then you would have a backend for front-end service that auto could aggregate that for the front-end applications. And we move to a model like this. This is what we do today. And I'm going to explain why it's so much better. So today what we do is, again, the exchange outputs everything to Kafka. We can operate with Kafka streams or Flink jobs on that data to pre-process that data in real time. It's very fast. Then we use Druid with a provider imply. By the way, because we are in expanding phase, we prefer to use software as a service today. In terms of cost efficient, might not be the best if you really think about, or you could save some money if you have like on-prem or some, possibly, but our focus is fully on delivering value to customers at the moment. So it's better to pay the price and keep moving fast than actually have to manage all that infrastructure yourself. And it's a choice. It's a conscious choice we made. And eventually, in a few years, we might decide to, okay, now we want to maximize the profit, what we have, then we could easily cut costs doing a lot of things on-prem or different models, right? It's a very conscious choice. So this goes here, and then the nice thing is we don't have any connectors between those two. Druid is native also from the Apache Software Foundation. It has a native integration with Kafka, which helps a lot because the data is already in Kafka. So we don't have to manage an extra connector or anything. It's a running job inside the Druid cluster that's reading the Kafka, doing transformations without any intervention. We don't have to, I don't know if we manage connectors, they're really nice, but it's one more piece of software for you to manage. You have to spend engineering time. You have to do a lot of work, maintain it. And believe me, it's hard work sometimes. So you don't want to do that. So this is one of the reasons we pick Druid. And the nice thing is you can also backfill. Let's say there's some calculations, you had a problem here at some point, you had a mismatch, you want to fill, you can backfill to CSV, to S3 buckets, or even APIs. Basically you can fix anything on the time, on real time. When you had the other model, it was very hard to fix things, right? Because you have projections, and the projections is built to replace. It's much harder work. And in terms of flexibility, in the other model, whenever we had to launch a new crypto asset, we would have to create tables, for example, for those projections. We would have to change the job to operate on those new assets. Things like that was a manual process. Right now, we don't have to do anything because everything goes to the same topic. The producer sends. This engine is clever enough, based on the data that is in, to already create the new model on tables, right? So this is much faster. The freshness is much better, and it's a simple architecture. I love simplicity, so whenever I see very complex diagrams, the first thing I usually think is how can I cut half of it and make it simpler. I believe this heavily, that simplicity is in the core of good engineering, and I see, and sometimes it's impossible, of course. Let's go, but like you should really aim for simplicity, because over time, the longest cycle of the software is always maintenance. Don't be fooled. It's not about building. Building is really important. You need to do it right. But you're going to spend much more time and much more money maintaining it over the years than actually building it. So you really need to think about this beforehand. This is a little bit of the results, right? Once we stopped using the old model, the load on our main database reduced like 40%. It's a bit hard to see because of the long period, but you see it's going down. And this is the tables we deleted. We deleted like, I don't remember, almost 5,000 tables, because you have to think for every asset you would need to build one table to be a projection of 15 minutes, 1 minute. And we have over 400 assets. So times the different ranges of candles. And that's, again, we deleted all this. So our main database today is much better. We have less tables to maintain. We have less load. So we can operate better on our core business here. And we introduced the Druid with this architecture. Now, the Druid architecture is a bit complex, but it's a bit like Kafka. It's a complexity created to be able to scale in real time, to be able to scale without downtime. And for a business like us, it's really important. The way Druid works is that it separates different components, and all this JVM, this is external, you could change, but the Druid is this part. And it's also very clever on how it does the processing. I'm going to show in the next slide a little bit better. But basically, let me see. Here you can see better the responsibilities of each node. I'm not going to go exhaustive over this. The application, the presentation is shared as well if you want details. I think it's not the main goal here for me. But what you need to think is, the way it does, it has the middle manager that connects to your Kafka cluster, create jobs, like the same way you have a Kafka client that creates multiple, that you can do parallelism through creating a consumer group, and then you can have multi-threads processing each one from one topic. Druid does this automatically. Yeah, you can see this here. So I can go back later. So you have a topic. We use Confluent in this case. It's a Kafka provider. Again, we use SaaS because for us, it's time to market. What's the goal? And then you have multiple partitions, and Druid can do this directly, connecting here and doing pre-processing on the data. And also the advantage of this is a bit subtle, but it's really important in this solution, is what this does is that when it's doing this, it's already processing the candles in memory. So if I have 5 entries for a specific asset for Bitcoin, 5 Bitcoin trades, I can tell Druid, okay, aggregate already and give me the mean, the max, the data I need from the candle in one single point. So instead of I stop having, and then when I query the aggregated data now. Well, why is this important? Because before, if you would query the fields to get the most up-to-date data, it's unpredictable. If you have a very hot market, I might have 1,000 fields, or I might have 2,000 fields. It's very hard to predict the performance and the scalability of this. Now, when you do this, the output starts to be predictable. I know in 60 minutes, I'm always going to have 60 base points. Because if you have 1 minute candle, I'm going to have, you see the advantage there? You really reduce and make the load on the other side much more predictable. And this helps you to get scalability incredibly, and predictability in terms of what you do. Here you see a bit more details. Then the very important part I want you to perceive here is when how Druid works is, so it streams the data. These are the real-time nodes. So when it's reading the data from Kafka, it's doing the aggregations in memory and creating the candles in this example. And then eventually when the window closes, let's say the last minute's passed, now I can close that candle, I can insert. It inserts on the deep storage and the historical nodes. The historical nodes are multiple machines separated by segments, so it's a little bit like Kafka, if you know, so it can horizontally scale, so you can have as much as you want, you can just put more machines, and it will grow without having downtime. And when you do a query, the client query the broker query the historical nodes for the historical data. It's a bit like MapReduce. Every node does their own processing, sends back to the broker, but the broker also speaks with the real-time nodes to get the real-time data, which means data that's still in memory, very fast processing. It's already available. It doesn't need to be persisted. It's already available to be queried. So you have that data already for your customers to receive. So this is one of the most important aspects for us because, again, we want to reduce the time between a trade happens and the time that you as a customer receive the update of that information. And this helps us a lot in terms of predictability and making very fast demonstrations. This is the current request time for the candles from the customer perspective. Again, this is a human base, so we don't care about those microseconds you saw before. That's machine. This is outside that engine. And this is, you can see the average SQL time. It's between 60 and 20 milliseconds, a bit more. And the P98, it's below 400. Again, this is for the app, it's for the browser, so it's more than enough for humans. It's like, you basically don't perceive much more than that. A little bit faster, we can get there, and we will, but that's how where we are. So to wrap up, I didn't check my time. I think I'm on time, yeah. So, what did we get with the change, right? We get better time to market. When we launch a new coin, it's much easier now. We just create, the output goes there, it's ready to be consumed by the applications, there is no intervention. We get also much better support. Our tickets in support also reduced a lot on this front. We don't have calls anymore about this. We have much better maintainability. The costs are lower because we don't have that cron job. Everything is in the Druid cluster. Our costs reduced from approximately 35K per month to about 15K per month to maintain this solution. So it's a very big win, and everything is better. So it's a win-win in all scenarios. The stability of the environment is much better. The scalability, which is very important for us to be able to scale from 10,000 requests per second to 50, 100,000 requests per second if we need, it's there, so we can just scale the cluster in real time, no downtime. It creates more nodes, it creates more query nodes, it allocates the memory hours, it caches everything. It's really much more efficient. The data is much more fresh, so from the moment that's traded to it's available, it's better. The performance is quite similar for the query time, because again, once you do the projection is in the database, the query time is almost the same. But if you compare the full life cycle, it's much faster, right? So understand the difference there on the query time versus the full cycle of that data. It's future-proof because we can now expand across the Europe and the globe without having to worry about scalability on that front. It's done. You just keep growing. There is a nice API client, and it's much simpler. So this is really important. And for this slide, is the most important for the whole presentation. I need you to pay a lot of attention. We are hiring, so if you want to join us, go and talk to us. We are in Amsterdam again, a big company, very nice company to work for. We're in a scale-up phase. We're not a startup anymore. We are a profitable company, really doing really well. So feel free to take the opportunities. We have some TA colleagues here as well. We're looking for good engineers to help us conquer Europe and conquer the world. So it's a really cool moment. Thank you very much. And I'm open for questions. And also after that, if you want to talk to us, feel free. Questions? No? Yeah.
Thank you for the presentation.
Yeah.
Maybe you can tell a little bit about nearest challenges, technical challenges. Why the nearest one?
On the near future.
Yeah, maybe the near future.
The near future, it's build new products on the trading area. Like right now, we offer traditional trading through like retail trading, spot. You can buy. Trade, but there's a lot of products that we don't have yet and we're building. For example, is the capacity to have margin trading. What's margin trading? Is that you can lend some money to buy something in our platform. This is very common in traditional platforms we don't offer yet. trade 5 products is something we're starting to discuss again to enable you to buy traditional stocks through a network in crypto, and you could just buy in the same application. You could buy stocks from different places. Those are products we're discussing. Another product we're discussing is to start doing derivatives like futures, and I don't know, it's a more advanced market. It's less for retail customers. It's a big market as well. So there is so many products we have to build, and now that we have this platform, we have the confidence to build, because without this core platform, it's very hard to go in that direction, right? Because you launch new products, you overload your system, you are down, people stop trusting you. It's a financial institution. You need people to trust you, right? That's really important in this business. And now that we rebuilt this core, we are ready for it. So there's a lot of products we're launching. We are like full pace in terms of product implementation, and yeah, it's a good moment for us in terms of building. And we deploy every day, multiple times per day. That's an important thing. You're developers here, so that's the happy part. Like, we are really modern in terms of deployment. It's like you have full control, and we deploy a lot. We are very fast. We deliver things, and we build a lot every quarter. Like, it's not like you know, I know I've worked in many places. Sometimes it takes you months to be able to deploy something. You keep building. We don't do that. We deploy every day. We deploy all the time. We have the modern architecture, Canary releases, and gradual rollouts. We have everything implemented to enable us to do that and give you confidence, right? The pipelines, it's all modern, which is the nice part of being in a new company, right? It's more that doesn't have so much legacy. So it's really cool. Yeah?
Thank you again.
Thank you. Yeah.
I wanted to ask about those cron jobs you mentioned, that they were quite heavy. Just to get a little bit of idea why they were so heavy.
Again, because we trade over 400 assets, I want you to think about this. And to create the candles, you have different segments for each candle, right? You have candles of 1 minute, of 5 minutes, of 1 hour, of 1 week. You have different segments of candles. So, and we have the field, the trades. Trades are happening. You need to parse those trades and create projections for each one of those segments, for each one of the markets. So it's exponential in terms of how much it grows. Well, let's say only Bitcoin. Let's say you're talking about Bitcoin. You want to show data for 1 minute candle, 10-minute candle, and let's say 1 hour. Let's make it simple. We have many more than that. You would have to get all the fields from Bitcoin. You would have to calculate those candles for each one. It's a cron job, right? You have to query. You can get 1,000 or maybe 5,000. It's unpredictable. And now you have to calculate the mean, max, the open, close, and the volume for each one of those segments, inserting databases as a projection. And now it's available to be queried by the application. So only these, we're talking about 3 tables, right? And we're talking about calculating this for 3 tables. Now, each asset has like 6 or 7 ranges, and we have almost 400 assets. So we used to have 4,000, 5,000 tables. You have to read that, calculate, insert to be able to do projections, and you can imagine how heavy this is for a database. Of course, one option would be split all these databases, but there's problems on that as well, because you want to consolidate the number of assets the customer has. Customer wants to see their portfolios and things. So it's like everything in IT. It's a more obvious architecture in terms of Chrome, but at the same time, in terms of scalability and proof of future, it's way behind. It's like databases. Even we use the biggest database available in a cloud provider. Like really, honestly, at some point we were using, I don't think we are anymore, we clean a lot. And it could not sustain the load. It's not, at some point you have a bottleneck there. So that's why. So now we have a much more future-proof. It's no problem, we can keep growing, and it's, yeah? Another question? I don't know if I have time, yeah? We don't know. For those candles, they represent our own exchange. For other use cases, we do use external market data. So we have those use cases where we connect to different providers and we calculate. Like we have that to see if our prices are deviating too much of the market. All this is in place. But for this specific solution, is about the trades that happen in your own company, right? So the candles represents the reality of our own exchange. So we don't use external data for this specific use case, but for other use cases we do. Yeah. Yeah? Because, well, the candles represent the trades you did in our company, right? We don't want to show a value that to our customers, it's the price. It's the same as um, we want to show what's happening in our exchange, so you can make a decision to buy or sell. And well, maybe there's a small deviation with other there, but doesn't represent our order book if you are looking at external. So we want you to be able to make a factual base. You know what I mean? Because you use Candle to make a decision to buy or sell, and it should be what you're buying. But that's why. But for other use cases, we do consolidate data from multiple exchanges. Yes.
Yes, but you have the case that everything you sell is for everything you sell you have to have a candle.
Yes.
Okay. So you have prices for everything.
Yes.
But this order book doesn't. So for example, if you don't have a trade for specific symbol,
Yeah.
let's say, or you
It's empty.
from other providers that will provide the price that you are close to.
We don't do that in the candles. If you look at the price history of the asset, we do that. But for candles, we don't do, because we really want to represent. I don't know if it's a business choice, to be honest, in that sense. We don't do that. If there are no trades in our exchange, you see a blank space there, you don't have that candle. And then you know, okay, and maybe you make a decision, that specific asset's not so traded at Bitvavo, I might trade somewhere else. So we show the real data to their customers, and they can make the decision there themselves. Yeah. Exactly, and we're showing the volumes of our exchange. Exactly, that's the point. Yeah? Yeah, question?
I have a question. I think it's more regarding less technology and more about the business.
Yeah?
It's more about where the stock prices came from.
From the offer, it's like anything. It's about the demand and offer. Someone wants to sell.
You hire some company that provides this price.
So yeah, so how it works is people like us, we can have Bitcoin, and we also have our bank account. So that's where it starts, right? I can say I want to sell my Bitcoin and I want 90K for my Bitcoin, and you might decide I want to pay 89, and then we don't match. We go to the order book. It's waiting. Someone, when it's crossed, it doesn't match. Now, to provide liquidity, we call this liquidity, which means there's also always something available for you to sell or buy. It's the same as traditional finance. We have what we call market makers. Those are professional trading companies. You have examples in the Netherlands like Optiver. It's a global company. You have flow traders. There are almost every country there's a few examples. Those companies, they operate very fast, and they offer very small margins on what people want to buy and sell, but they have a contract to guarantee liquidity, to guarantee that you as a customer always have from where to buy and or how to sell. And yes, though there is this professional trades. Every exchange has those. It is called market making. There is the Investopedia. If you want to know more, it's a great place to learn about investments. It's like Wikipedia for investments, and it's amazing. And you can see what's a market maker, what everything, if it's a bit of a new language, and it's available there. It's really cool. So it's a completely new, different business. Yeah. Yeah, you're welcome. Okay. You kick me out when I have to go. For now, I'm good. I'll keep going.
How do you assure the scalability? Like if you are using Spring microservice, the startup can be a bit long, so do you use some native things?
We don't use it yet. One thing in a company like us that we try to do is very stable environments, and because everything is coming from Kafka, of course we use Spring Kafka. It's quite stable, quite good. So in general, we don't do that, and we also have always multiple, like because Kafka is distributed, we always have multiple instances of any application. And then for us is when there is a startup, we use Kubernetes operator for that area. In the core exchange, there's no Kubernetes, of course, because of the performance. But when you go out, and then it deploys gradually, and we just run all the time. So no, we don't focus on that yet. Again, we are fully focused on delivering business value. We know it's something we could look and invest, but it's a trade-off in terms of investing our engineering time on optimizing, or once it's running, it never stop. So, and the performance is great, right? So we don't do that right now. Yeah. Okay. Thank you so much. Oh, I have more questions.
More business related.
Yeah.
What about what's the process of sharing data with the Dutch authority?
Yes. So yeah, of course, you have to do that. We are doing an integration with Nasdaq, if I'm not mistaken, right now. So they basically monitor and they know everything we're doing, and they have basically they do that. We also have, of course, internally a team that's our regulatory tech, which it's reading everything that's happening all the time, and preparing reports for authorities. Everything is in there. Yes, yeah. It's heavily regulated now. Yeah. So we have everything that you can imagine that we need to do. Yeah, we have to do that. Reports and auditing and etc. Yes.
I mean, more technically.
How we do it? Again, that's the beauty for us of using Kafka. The data is all flowing to Kafka. So basically, we plug in those real-time applications on Kafka with Kafka streams or Kafka clients or Flink, and we are calculating this on the fly and generating data. And the advantage of that is that you are always processing data as it arrives. It's a bit harder to get big bursts, right? Because it's not like you're waiting 2 minutes to query somewhere and you don't know how many data it was generated in the past 2 minutes. It's you're processing data as it arrives. If that starts to get pressure, you can scale before it actually explodes. Like it's more predictable. So yeah. So it's we use streaming. We're shifting left. It's called more processing in real time as much as we can. It's been very successful, I would say, and we're ready. We're really ready to keep growing. So it's a very good feeling compared to when I started like 3.5 years ago in the company, or 4 years, where we would spend weekends just patching stuff because it was going down all the time. Yeah, cool. Thank you so much for attending.